In this project, we'll take a look at creating a basic character controller using a finite state machine so that you can instantiate characters in the little 3D world and move them around. We'll be using JavaScript and Three.js, like always, and we'll be diving a bit deeper into the animation system here, looking at some of the classes like animation mixer, animation action, and animation clip. Three.js has great support for animations, whether you're looking to do some simple animations or something much more advanced like this soldier here. Three.js has you covered. You can see here, there's a whole bunch of ways you can blend multiple animations at once. Like, look, I can create a sort of shuffling walk by mixing idle and walk. Anyway, what we want to do is take these capabilities that Three.js exposes and wrap it all nice and neat into a character controller that you can conceivably just drop in and use in your own projects. So let's get started. Before we begin, make sure you subscribe to this channel and on Twitter so that you're notified when new videos are released, and you can also get previews of what's coming up. First thing, we'll start a new project, so drop down to the terminal and create one. I'll call it Three.js_tutorial_character controller. And once we have that, we can add a few simple files like the index.html and main.js files. In a previous tutorial, we covered loading animated characters, so if you haven't watched that, I covered a lot of the basics of loading animated characters there, so definitely watch it before you watch this one. So we'll use the code from there as a starting point, just a bit of copy-paste to get things started. We'll also need a bunch of animations, so head on over to Mixamo where we can help ourselves to a few free, really nicely done models and animations. Specifically, in our little example, we'll be making our character stand around, walk, run, and do a little dance, depending on which keys we press. There's a really nice selection of stuff here. I grabbed this dance cycle along with a nice walk and run cycle. Should be fine for what we're doing. Notice that I download the animation separately by downloading this without the skin. So when we hit download, we can just select no skin, and that just gets us the animation data without needing to load the rest. Now that we've got our animation data, let's start by creating a few basic classes. We're going to make a basic character controller class, which is going to represent a single animated character in our little world. We'll also make another class, basic character controller input, which will be responsible for listening for keyboard input and recording keys like up and down, that kind of thing. Lastly, we'll make a finite state machine and state class. We'll fill their implementations out in a second. Now you could easily put them all into one big class, but the reason we're not going with this one Uber class is simple. By decoupling these classes, you can in theory drop in replacements, like say if you have the basic character controller and you want to make an AI, you can simply drop in an AI input in place of the keyboard input and voila, you have an AI character. It's just neat and tidy and saves you time in the long run. So now, the basic flow is like this. The basic character controller has an instance of an input, which will instantiate right here in the constructor, and it has a finite state machine. The character controller will load the FBX files associated with the model and animations, and then create a proxy class that will let the finite state machine communicate with the controller to change animations, that kind of thing. You could of course just give it direct access to the basic character controller, but I'll make a proxy class to avoid cluttering things up. The loading is all pretty simple. We load the main model file, which is what these lines of code do. Then we load each of the animations, and we store the animation clip and animation action from all of these in a dictionary called this._animations. The keyboard input class is pretty simple. All this does is set a few document listeners up for the key up and key down events and record the relevant ones. There's really not much in here beyond that, no special processing of anything. We're mostly just interested in walking running, so we'll record AWSD for walking, the space key for doing a special animation, and the shift key for transitioning from walking to running. The input here will get directly passed to the finite state machine to be interpreted, so not much to see here. The real guts of the logic is here, in the finite state machine. So, quick aside. Finite state machines are a really simple way of modeling the possible states and transitions for a character. Imagine we've got this character, and we'll model some simple state for it. Initially, he's in the idle state since that's kind of like the default. Nothing's happening here. If you were to press forward or backward, he'd be walking. So we add this walk state, and you transition to that from the idle state when the input was forward or backwards. Similarly, when you're walking and you stop pressing those keys, we transition back into the idle state. Our character isn't going to have a ton of states since this is just a tutorial, but here's the final finite state machine where we have idle, walk, run, and dance states. Let's code this up. So back in the code, we have the finite state machine class, and this has a few public functions. There's the setState function, which first signals the old state that it's exiting and sets the current state, and then notifies the new state that it's active. There's also an update function that gets called every frame and passes the frame time and input to the currently active state. Now we'll make a character FSM class, which will just be a child of the general finite state machine. And I just do that so I can add the character's specific states here, like idle, walk, run, and dance. These add state calls, what we're doing is passing the name of the state and then the class that will get instantiated to represent that state. So for instance, when we switch to idle, the finite state machine will instantiate an idle state instance. Let's go over the states now, and we can see how they transition from one state to the next. Beginning with the idle state, when we enter the idle state, we want to set the character's animation to idle. So here in the enter function, this is responsible for playing the idle animation. If there was a previous state, like let's say the character was walking before, all this code here does is tries to crossfade them, so the old one fades out and the new one fades in. Here's an example. On the left is where we do the crossfade, so the character kind of naturally comes to a halt. On the right, there's no crossfade, so it kind of abruptly switches from one animation to the next. You can see that one kind of looks jerky and unnatural and the other looks pretty smooth. Next, in the update function, remember from the diagram that it can transition to either a dance state if you press the space, or a walk state if you press forward or backward. So in the update function here, we'll check the input. If they're moving forward or backward, we set the state to walk. And if they press the spacebar, we set the state to dance. Next, let's look at the dance state. This is a pretty simple state. The enter function is doing two things. First, it's playing the animation. Again, we crossfade like the idle did, but we also set some different parameters. Specifically, we only want to play this once, so we set 3.loopOnce here and clamp when finished to true. That just pauses the animation right at the end once it's done. The other thing we do is set an event listener to wait for the end of the animation, because once the animation is done, we just set the state back to idle. The dance state doesn't do any updates, it just plays and then exits. Moving on to the walk state, this is pretty similar to the idle. In the enter function, we start playing the animation, trying to crossfade if there was another animation before it. There's just one gotcha that I'll walk through. If the previous state was the running state, we also want to smoothly fade in from that, but the legs might be in a totally different place since the running animation might be halfway through. So we don't want to just start the walking animation. Instead, we skip ahead in the walking animation a bit, the same percentage as the running animation. That way, when we start crossfading, you get a super smooth run to walk. Let's watch without this. On the left is if we just crossfade, which kind of looks okay, but not great. Depending on where the legs were, the model kind of stumbles. If you catch it at the right moment, it looks great and seamless, but at the wrong moment, and it's stuttery. Now on the right, we have the animation synced, and it always looks smooth. Doesn't matter which leg is going forward or where they are in the cycle, we transition smoothly from walk to run, and vice versa. Now the update function for the walk state is pretty straightforward. You check if you're still walking, otherwise revert to idle. And if the shift key is being held down, switch to the run state. And I'll just skim run state quickly because it's a near carbon copy of walk state. The only difference here is in the update function. If they're not pressing the shift key, revert to walk. And that's it. Once you've done all that, in the basic character controller class, if you add some velocity and direction, you've got a little walking character. It's not perfect, but this should get you started. You can see I can walk around a bit, looks pretty decent for the amount of work, and if I hold down the shift key, you can see he breaks out into a little trot. Run around a bit, and then once I let go of the shift key, he drops back into a walk. And if I let go, it stops altogether. Finally, if I press the spacebar, he dances a little jig. You could do so much more with this. Go back to Mixamo and get a walk backwards animation, or add some jumps, attacks, whatever suits your purposes. Hope you enjoyed this. If you haven't already, subscribe both here and on Twitter. You'll get notifications when new videos drop and previews on what's coming up next. I also chat with people and try to get a sense of what you all want to see next. Make sure to like the video and leave a comment about what you want to see covered in a future tutorial. The code is all up on GitHub, so go ahead, grab it, download it, do whatever you want with it. Cheers, everyone.